Okay, so have a look at the question. We will do this question, and after that, we could do whatever. Can you see everything? Yeah.
Yeah.
Cool. So, do you remember much about this kind of stuff? Parametric equations? Do you remember what they are?
Um, yeah, do you have to make T as a subject? But
Make T the subject? Well, you can sometimes, but not in this
they've
question.
given T, isn't it?
Yeah, so I think you might have done this, but like anything, the first time you do it, it's kind of in a rush.
Yeah,
you do a few exercises, then you move on to the next thing. So you kind of forgotten it, and you have to do
yeah.
it at least 3 times to kind of get comfortable with it. Yeah, and then quite a lot more times to get good at it. So dy by dx is what we're trying to do here. We're trying to get dy by dx. So parametric. I mean, parametric is a normal English word, but you don't get to use it so much in normal English. It just means, what's the best way of describing it? It's a thing that it basically is saying this is the parameter. This t is a thing that links x and y together. Normally, in normal kind of what we call Cartesian equations, x and y are linked straight away. It's like y equals x squared sort of thing. Y is whatever x is squared, all that kind of
Yeah.
stuff. Yeah, but these ones they're linked with a t, so you might do it. You could have a very different kind of table of values. When you do a table of values for x and y to make
Yeah.
a graph, well, this one's got a t stuck in there as well. So you go t is, I don't know, 0, 1, 2. Let's put a 3 as well, okay? And then you go, what is x, what is y, and you get a whole bunch of numbers. Let's just get 2 values. 0 is usually a good one because it's easy to work out. So x, let's use this one. X is 2 times sine 0. What is sine 0? Do you remember?
Um, Sine 0 would be 0.
Good. See, and this is one of the things you want to get really comfortable with. So we're revising all sorts of things. A sine 0, you should know the sine graph in your head. Yeah, it should not exactly, but you should you remember. Oh, that's how a sine graph looks like. It always
Yeah.
starts with 0. That's 90. That's 180. That's 270. That's 360, and blah blah blah. That kind of thing. Okay, so. It's all good stuff. We want to revise all of it and get really comfortable. It says 2 times sine 0. What does that equal?
0.
0. Cool. Are you using a headset? Are you with a microphone attached to the earphones?
Earphones.
Are you using it at the moment?
Yeah.
You are. Okay. I was wondering why I could hear some sort of weird feedback. But anyway, that's good. It's good that you're using it. So 0. And what is y equal to? So this is going to test your cos graph memory. How does a cos graph looks like? Yeah, so we're trying to figure out that. Y equals 1 minus cos to 0, because t is 0 in this particular case.
So that would be 1, wouldn't it?
Good. So cos 2 times 0, 2 times 0 is 0, cos of 0 is 1, 1 minus 1, 0.
So,
Yeah?
yeah.
Okay. So if you've got a graph, this is your x-axis, that's your y-axis, you just got one dot, because it's these things that actually make the coordinates. Yeah? So that was a bit of revision about parametrics, just to get comfortable with it again. Now, how comfortable are you with reading stuff in radians?
Um,
Like,
it's slightly more difficult than degrees, obviously, but
Okay, so what you want to do is not memorize how radians work. Okay, what you just want to remember is, let's just think about cut it into 4 parts, right? All you have to really remember is that is pi.
mm,
Yeah, and then
yeah,
everything is you're never expected to remember what 1.65 is in degrees. Do you know what I
yeah,
mean? Yeah,
yeah.
1.65 radians. What is that? It's always about in terms of pi. Half a pi. What's half a pi? Can you guess what half a pi is?
90.
90. You just have to remember that kind of stuff, yeah?
Yeah.
Or a third of a pi. Oh, that doesn't look like a third of it, that's more like a quarter of a pi. Let's make it a third of a pi. How would a third look? Maybe like that, yeah? So pi over 3 is going to be how many degrees?
60.
Yeah, that kind of stuff. So whatever.
Yeah.
So that's the idea. You want to think about it like that, because maybe the first time you do it, or I don't know, you've been doing it since C2 or something, I think. Yeah, that's
Yeah.
right. Maybe a lot of people think of it as, sometimes the way it's taught is a bit strange, that you think you have to remember the decimal places. It's just simple fractions of
Mm,
pi. Yeah.
yeah.
Okay. So anyway, so we're talking about over here. We're talking about minus 90 to positive 90 degrees. Yeah. Anyway, that's just a kind of a revision of parametrics, a bit of whatever. Now, how do we work out dy by dx? Do you remember anything about this?
So for x, it would be dx over dt, and then
Yes,
you
yes,
times it
basically,
by dy over dx.
exactly. So dy by dx is basically dy by dt divided, where should I put? I'll put the divide like that, divided by dx by dt, because
You can flip
differentials
it, yeah.
are like fractions, yeah. Okay, and obviously this gets flipped upside down because you're doing a divide,
Yeah.
yeah, and then it cancels out and you get dy
Mhm.
by dx. So that's basically what we have to remember. So let's get dy by dt. What does that equal? So we're looking at this stuff here. Let's see what you remember.
That would be
Say it again.
2 sine 2t.
2 sine 2t. Okay, yeah, that's good. And the 1 disappears to, yeah, 2 sine 2t. Okay, now I'm just thinking, why is there a slight weird sound coming when you're talking? Just a bit of an echo. That normally happens when you don't have a headset. Maybe. Were you using a normal PC, not a laptop? Or a laptop?
Laptop.
A laptop. Are you sure? You know, on Skype, could you just make sure that it's using your headset microphone rather than your laptop microphone? Or something weird like that? Just check. Although your sound is very close to the microphone, so it kind of suggests you are using a headset, but anyway. Do you know where to check for that kind of stuff? It's under
Is it?
Tools on Skype.
Yeah.
Tools, and then Audio.
What do I test it?
Oh no, don't test it. I mean, as long as it's got, you can recognize your headset or whatever. Can you, on the drop down for the microphone that you're using, does it say like headset or something that you recognize?
I think it's working
Yeah,
now.
cool, cool. Okay, fine. Anyway, so that was good. You differentiated minus cos 2t very nicely, because cos differentiates to minus sine, but because it's already minus cos, it becomes positive sine, and you basically did really well. That was good. Okay, so we got dy by dt, we want dx by dt now. How do we do that?
That would be minus cos t. No, minus 2 cos t.
Great. Minus 2 cos t, that's it, yeah. Okay, so we got that, and therefore, let's put it on the side for a second. dy by dx equals... You don't really have to do it in one go. I'll just write it down, yeah? So you got... let me get... Sine 2t divided by minus 2 cos t. Cancel, cancel. What do we do with the minus? I'm probably asking a easy question and thinking there's a harder answer or something, so just put it in the front, that's all I meant, really. Cos t. Alrighty, okay, we've got that. We've got dy by dx, yeah? Does that make sense? And can we simplify that?
Sub t.
Say again?
Sub the t in.
Sub the t in. Oh yeah, I forgot about that. Yeah, t equals pi over 6. Okay, so pi over 6. Let's write that down so I don't forget. Okay, and that is going to give what? Okay, so sine 2t. So what is 2t equal to then?
Pi over 3.
Pi over 3, excellent. So pi over 3, basically like 60 degrees. Why, and what do you think sine of that is? That's how I think immediately, yeah? You should kind of know. Do you know what I'm talking about here? Why am I drawing that triangle? It's a well-known triangle. What should this length on the bottom be? You gotta know it. 1. Do you remember this? Is it coming back?
Yeah, 1. Yeah.
What is the hypotenuse?
1 as well?
Nope, 2.
Or the 2.
Okay,
yeah.
there's only 2 triangles you got to know. Is one the one I'm drawing is the one, and you have to kind of know the tiny story behind it. And the tiny story is, once upon a time, it used to be an equilateral triangle. Then you cut it in half, and the rest is obvious. Yeah, and the other one is, it used to be, I don't know, a square. You can imagine it from there, and you cut it in half. You got 45 degrees, and that was one, and then a little bit of Pythagoras will give you that's root 2. Yeah? Okay, so there's only 2 triangles you've got to know, and they come up so much that you really got to know them. But when I say you've got to know them, just know the rough story and use it a couple of times, and you'll know them. Because I don't like, you know me, I don't like memorizing too much stuff. Yeah. So we've got pi over 3, which is pi over 6. So when you double, 2t is pi over... So, I'm saying it the wrong way around. We've got pi over 6 to start off with, but 2t gives you pi over 3, okay, which is 60 degrees. Now, sine of 60 according to this triangle, and I haven't done all... Actually, what is this... what is the opposite length equal to?
1.
So this is the angle. When I say the opposite, I'm talking about this side. Yeah. So you know what I'm talking about, isn't it? When I say the opposite side. Yeah. When you're talking about opposite adjacent hypotenuse. So it's not 1. What is it?
Isn't
Let's do. So this one you kind of have to do. You got to do some Pythagoras. So you got a piece of paper and pen and paper?
Yeah.
Yeah? Go for it. Pythagoras it. It's really important that you do stuff yourself rather than just be told stuff, because that's how it gets stuck in your head. The more you physically do stuff.
Is it 3?
Think again.
Root 3.
Root 3, yeah. Okay, so anyway, a bit of Pythagoras gave you that. We know the triangle. Now, again, what is sine 60 equal to?
So it would be root 3 over 2.
Root 3 over 2, good, because you shouldn't visually know that is this side divided by that side. Yeah, not the soccer. Do you still use SOHCAHTOA? Not really, you shouldn't.
Not really.
You shouldn't. You should think, that's my angle, this one is sine, tan is over the 90 and cos is over the angle. Yeah, all teachers do that as well. They don't do SOHCAHTOA, that's what you start off with. Anyway, alright, okay, so we know it's root 3, so equals minus root 3 over 2, massive line for the bottom part of the fraction, and then cos pi over 6, so pi cos 30. What's that getting? This triangle should tell you the answer. What is cos 30?
1.5.
So cos 30, it should be also root 3 over 2. Can you see it? Because sine 60
Yes.
equals, yeah? Because cos, like I said over there, is the... what am I talking about? What am I talking about? No, I am talking about the right thing. I thought I was going crazy for a second. Because that is 30 on the top corner, isn't it? Yeah?
Yeah.
Yeah? So cos is the... what's it called? The adjacent over the hypotenuse. Are you okay? Do you know what I'm talking about?
Yeah. No, it's just that I was using the other angle. So,
Yeah, I was using it for a second, but some of the doubt myself. So, anyway, root 3 over 2, it's the same thing, yeah? So we can make it complicated and try to cancel, think of the root 3 separate from the 2, whatever. Just forget that. What's the answer?
-1.
-1. Anyway, so that's all -1, and that's the answer. Well done for remembering that we're supposed to be sticking this t equals pi over 6 into it. Okay, find a cart. Have you got any questions about that? Was there, is there something we?
No, it's more later on, I think. Later on
When
in
you
the
get more
chapter.
stuck, yeah? Okay.
Yeah.
Alright, so
Once.
find the Cartesian equation for C in the form y equals whatever and k. Oh, well, we have to find k, right? Okay. So, stating the values of k, yeah. Okay, so, what is a Cartesian equation? I kind of mentioned it, but what is it? Take a guess. Sometimes it's good to guess. It gets the brain working more. Yeah.
So you sort of end up with 2 equations.
Nope. Easier than that. I'll give you a clue. Cartesian equations are stuff that's you've seen for
Of a
ages.
curve.
Yeah. It just means a normal equation, basically. Yeah. Okay.
Okay.
Parametrics are the weird ones. Cartesians
Yeah.
are the normal ones. Okay.
Yeah.
So, yeah. So we're gonna do that. We just want y equals something with x's in it. They kind of said that already. Yeah, they already said that.
Mhm.
But because you could get something like y squared equals x squared, I don't know, maybe they're trying to avoid that, yeah? But that's what Cartesian means, y and x is in it, just the normal stuff. Okay, so how do we do this? One technique to gets you from parametric. No, I mean 2 techniques, but 1 technique when you've got trigonometry going on. Yeah? How do you turn the parametrics into normal Cartesians when you've got trigonometry going on? It's the age-old, yeah? Age-old, what are you saying? That's what I say in my other videos. Okay. Sine squared, my other videos about how to change your life.
Mm.
Do you know those ones? You probably don't know what
Yeah.
I'm talking about. Do you do? You know actually that I make those videos. Okay, that's good.
The one on your website.
Yeah, exactly. Yeah, because I switch between different videos. But yeah, I do like these daily videos.
Mm.
Okay, so sine squared plus cos squared. I'm being really lazy. I probably should write t or x or something, right? So sine squared plus cos squared equals.
1.
Yeah, and that's the thing you just use over and over again. Okay, so but it looks a little bit far away from that, doesn't it? Look, you can't really see that going on. So what does that remind you of anything, this stuff? Like, I mean,
Yeah.
does that remind you how to do this? Because like I said in the beginning, you've just rushed through it once. I don't know how much you remember.
So
Does it trigger
I can
you?
see with cos 2t you can use the
Say that
double
again.
angle.
So what was it? The
With
C?
the cos 2t, 1 minus cos 2t,
Oh yes.
You can use the double angle.
Yeah, good stuff. Yeah. So, alright, okay, so y equals 1 minus cos 2t. What are we going to replace the cos 2t with? Double angle. Okay, that's right. You're using double angle. What is that double angle? So that's right. Equals. And don't worry if you've forgotten.
No, I'm just thinking which one you would use of the three.
Yeah. Okay. So. Okay, let's think. Okay, the basic one that they all come from are cos squared t minus sine squared t. Yeah?
Yeah.
And then from that you can get either 2 cos squared t. I hope this is right, I haven't done it for a while. 1.
Minus
Yeah? Or what was the other one?
1 minus 2 sine squared t.
Yeah. Alright, okay. So, and we're trying to get to a situation where we can say sine squared plus cos squared equals 1. Okay, so let's just leave that for a second and think. Let's look at the x one. X equals 2 sine t, and we can see if we're trying to get sine squared plus cos squared equals 1, well, we can get sine squared, can't we? We can start off with x equals 2 sine t. What would we do next? You do x over 2 equals sine t. Yeah? I'm not surprised you couldn't get the answer straight away, because we need to revise this stuff, although you probably know the rough idea in your head, but you've only gone through it once. Yeah, so we've got sine squared t. Whoops, I forgot to square it. Yeah, remind me when I forget little things like that. Yeah, they're important. Okay, so we've got x over 2 squared equals sine squared t. Now that tells you what to do here.
You can substitute into the first equation.
You mean this one, basically, yeah?
Yeah.
Okay, good. So, let's carry on with this thing here. So, 1 minus 2 cos squared t minus 1. And then it gets easier and easier, isn't it, yeah? So, I should just write equals. So, 1 minus minus 1, I'm just going to deal with that. That's 2. And then minus 2 cos squared t, and you kind of feel like you should be factorizing that, isn't it? It's one of those habits that you kind of get into, you should kind of get into, like, oh, factorizing, that kind of somehow makes things easier. Don't know if it necessarily does. Sometimes you go down an alley and then you have to come back. Yeah, so you go, okay, yeah, whatever, and let's swap things around. Can you see it?
Minus 1. Y over 2 minus 1.
Yeah, that's it. Yeah, I'm just double checking in my head. So you move that to the other side, you move that to here. So it's 1 minus.
Oh, 1 minus 1.
Y over 2. Okay, good. We've got that stuff. And now, what was the whole point of that? What was the whole point? Do you remember? How are we going to use this now? Because
equal to 1.
Yeah, we can say all this stuff, this x over 2 squared plus, guess what?
Y minus y, no, 1 minus y over 2.
Cool. Equals
1.
You got it. And okay, so interesting. Have we got the answer? Is that the answer we're looking for?
Okay.
Well, K is there as well, but we haven't got the answer yet. Can you see? What's wrong with our answer?
It's not in that form.
It's not in the right format, so we got to do that. Shouldn't be too hard. What should I do? Give me the steps.
Expand the bracket.
Do I really want to? I'm not sure if I want to.
Or just...
Do you know what I mean?
Yeah.
X over 2 squared, and that's kind of looking a bit interesting in a good way. That if one, I'm going to be a bit slick here, it's not like a standard thing you do, but it's something you should get a bit comfortable with. It's like this, they're both saying 1 minus blah equals 1 minus the other blah, yeah?
Yeah.
That just means that, doesn't it? We could go the long way around about it, yeah?
Yeah. Yeah.
With a bit of moving stuff around, but you can just see it, it's happening, yeah? So
Yeah.
y over 2 equals that. So we got the answer, right? We've got y equals fx. No, I'm always going to come with trick questions, yeah? So we're almost there. Oh, let me just plug in the power 1 second. So what do I have to do?
Times it by 2.
Times it by 2. Okay, good. Okay, where did I put the power? Here is the lead, and it's down there. Okay, there you go. Yeah, okay, so yeah, we got it. So y equals 2x over 2 squared. Okay, just remind me, by the time we finish this question, we got to do something, you know, that's troubling you in school or something like that, yeah? Alright, okay. We got to get the k still. K, where is that k? What is that k all about? So, yeah, haven't we got it already over here? What do you think?
What do you mean?
Okay, so we're looking for this k, isn't it? K over here is this k here. So, okay, I'm just trying to put you off by giving you all sorts of awkward questions. Okay, you tell me, how are we going to work out the k? You know we have to get this k, yeah?
Yeah.
Okay, so how are we going to get it? Ooh, I've highlighted too much. Yeah, go on, give me some ideas.
So we've got the equation.
Okay, which equation?
The one we did for y. So is k in the equation?
Okay, so
Oh, is it when you expand x?
Nope.
The bracket.
Expand x. Maybe you're saying it slightly weird way. Yeah, you use this equation because right now, do you know what is you know it says minus pi. You're going to convert from this to this, right?
Yeah.
Yeah, and the key difference is you know this pi over 2. I know it's in radians, but what letter does it represent? X, Y, or T? The radian stuff, the pi over 2, whatever. It's in terms of x. I mean, sorry, T. Yeah, and you want to make it in terms of x. So when you know that, then it's really easy. Yeah. So. Or maybe, well, how easy is it? What do we do? How do we convert from one to the other? How do we go from t to x?
Would you make t the subject?
Make t the subject. Nope. Okay, now this is the thing. It might feel complicated.
X into the equation.
Yeah.
X equal to 2 sine t.
That's the one. Yeah, exactly. That's all it is. It's actually a very easy thing, but you need to practice until it just becomes second nature.
Yeah.
Okay. So let's do it. Yeah. We've had a bit of practice with radians. Let's see how good you can do this. So what are we going to do first? What's our first step for going from there to there? I know you told me the right equation. Now what?
Put t equals pi over 6 into
Pi over 6? Why pi over 6?
the t value.
No. Where did pi over 6 come from? That was the previous question. That was this question,
okay.
yeah?
Yeah, I'm confusing.
Yeah, it's alright, I can understand, because you're still getting used to stuff again, okay? So, okay, yeah, so we're going with pi over 2, right? So, x, let's just write the basic equation, 2 sine t, okay, and we're going to stick, I like to keep it in order, okay, left or right, okay, so stick t equals minus pi over 2 into it, what does that give you for x? Should do a proper give sign, although it's a bit late for that. Alright, okay, so what does that give you? So first of all, we're thinking, what is sine of minus pi over 2? We know pi over 2 is 90.
It'll be minus 1.
Minus 1, cool. Yeah, and
It'll
you
be,
could, yeah, go on.
yeah, times 2, so it'll be minus 2.
Minus 2, great, we've got the first number. Oh, and that should probably tell you that's 2, right? Because k is a number,
Yeah.
but let's just do it anyway. This is all about practice. So, actually, it's obvious, isn't it? It's going to be 90, sine of 90, and double that, it makes it 2. Okay, so anyway, we've got k is 2. Great, okay, write down the range of fx. The range of fx, eh? How are we going to do that? What is a range?
The y... the y axis.
Yeah, it's the y values, it's the result kind of thing. The x is the input, y is the output, yeah, the range is the output, cool, the domain is the input, cool. Alright, so let's, how do we get the range? Any ideas? Give you a clue, it relates to the previous question.
Would you use the minus 2 is smaller or equal to x?
Yeah, because those are the kind of boundary values, aren't they? The minus 2 and the positive 2. Okay, and that often helps. It doesn't have to help you get the range. There's other things that limit the values, but because range is all about the minimum and maximum.
Yeah.
So not always do the boundaries give you the minimum and maximum. Sometimes something else does, but okay, so if we stick minus 2 into our equation, and I think maybe we should use this equation. Let's move this closer so you can see it at the same time. Let's move up there. Great. Alright, so yeah, so we stick minus 2 into there. What do we get? I wonder if that helps.
1 times 2.
Minus 2 over 2, minus 1, square it. Negative and positive numbers are not going to make a difference when you square them anyway, isn't it? So, minus 1 squared 1 times 2 is 2. So, okay, interesting. So I just write, what was it? X equals minus 2 gives y equals 2, and the same with 2, that's also going to give the same answer. So that doesn't seem to be helping all that much. We want to find a minimum maximum kind of situation. So although I said that would be your first guess, but it doesn't seem to be helping. So it's kind of good, because now we're getting to more of a range kind of question where you have to think a little bit more, and what we normally look for are kind of minimum maximum situations like humps. So let's think about
so when the gradient is 0.
Yeah, even that I'm kind of yeah. And how does this graph look like? Y equals 2 blah blah x over 2 squared, whatever. What kind of graph would you categorize that as?
Quadratic.
Quadratic, exactly. Yeah, and it's basically like one of these, but just a bit squished maybe. Yeah, it's got to be at 0. So the range. That's interesting. What is the range? Can you say straight away?
It would be any real number over 0.
Yeah. Yeah, exactly, yeah. The range of fx is, basically equal, greater than or equal to 0. Cool, whatever. Alrighty. Okay, so